Good evening. Good evening.
Okay. I think Mr. Rajeswaran?
Yeah, I'm there.
Okay. Nama start pannilama.
Yeah, I'm ready. You can start.
So that now it is. Mr. Nagappan,
Yeah.
ready?
Yeah, yes, sir. Can I go ahead? Yeah.
Yes. I think we can. I think we can. 1 minute, recording start பண்ணிட்டோம். Yeah, I think we can start with a good number. We'll start on.
Good evening, friends. It gives me immense pleasure to welcome all the participants today. And the speaker of the day, Mr. Rajeswaran Viswanathan, Senior Director of Capgemini India. And he's going to talk on the current topic, the latest, it's a trending topic, generative artificial intelligence and its impact. We are all eager to listen to him. And I also welcome all the members of CSI Chennai, IEEE CSM, ACM Chennai, on behalf of the organizers and Hindustan Chamber of Commerce. Just a word about the Hindustan Chamber of Commerce. It started in 1945. We are 78-year-old with 950 members. And we have done in the past, HCC is not new to all the three organizations. We have done so many programs thanks to all the three organizations, and particularly Mr. H.R. Mohan. We have done a program on ONDC and CBDC, Metaverse, monetizing using Metaverse, various programs we have done in the past. Just two announcements on behalf of HCC, and we have an event on Wednesday, 26th at 3:30 p.m. at the chamber premises, organized jointly with Guidance Tamil Nadu. I request you to attend, those who are interested. And then Saturday, August 5th, at 8 a.m., we have an Investment Saturday event at 8 a.m. With the breakfast meeting. Mr. Arun Kumar, Vice President, Head and Research Funds India, is going to speak. With this, I welcome one and all. Thank you.
Thank you, Mr. Nagappan. Good evening and greetings to one and all. On behalf of the organizing units, Computer Society of India, IEEE Computer Society, ACM, and Hindustan Chamber of Commerce, I once again extend a warm welcome to the speaker, Mr. Rajeswaran, members and colleagues from all the organizing units, and the delegates participating in this webinar through Google Meeting platform, and those watching the session through YouTube streaming. Generative AI has become the most talked about subject of late. It gained a lot of importance and prominence after the ChatGPT by OpenAI was launched during November 22. The advent of machine and deep learning, availability of data, and increased processing power of hardware have fueled the growth of language models, transformers, and eventually generative AI to facilitate the creation of text, image, music, animation, videos, as well as coding, to name a few. There is a mad rush to release variants of generative AI tools by tech majors, universities, and AI startups. The generative AI, though made beginning in 2017 at Google, it was not made public, keeping in view of the responsible AI in mind. By seeing its potential, Microsoft backed OpenAI launched the ChatGPT in late 2022 and started the momentum. While the generative AI tools increase the productivity, there has been concerns such as loss of job, bias, accuracy, mis and disinformation, and growing dangers in stability across the world. Some major economies are staying away from these generative AI tools and want regulations in using these tools as their impact is being felt in almost all disciplines, right from education, health, publishing, entertainment, manufacturing, social media, software services, and whatnot. It has come to a state that everyone is expected to know something about generative AI, and software companies are training their entire workforce to gain some knowledge to be competitive. Hence, we thought it is appropriate in organizing such a webinar on generative AI and its impact to create some awareness among our members. In today's presentation, Mr. Rajeswaran will broadly cover what is generative AI and why it is very impactful to all of us. He will also touch about what are the types of use cases companies are implementing, how can use cases like chatbots, cognitive search, etc. can be implemented, and finally, he will also discuss about what are the risks and what can be done about them. With this brief introduction on the topic, now let me have the pleasure of introducing the eminent speaker, Mr. Rajeswaran. Mr. Rajeswaran is currently the head of AI Center of Excellence in Capgemini, India region, handling over 100 people, developing multiple solutions. He is also a part of portfolio board in Capgemini for generative AI. As a generative AI specialist, Mr. Rajeswaran has built and deployed generative AI solutions in the past 2 years. With an overall experience of 28 years plus, and as a head of AI Center of Excellence, he manages multiple solutions using machine learning, deep learning, and generative AI. In the past over 30 years, he has worked on multiple AI projects in domains of manufacturing, pharma, banking, and insurance. Mr. Rajeswaran's qualifications include BE in Electronics and Instrumentation, MS in Computer Engineering from Texas A&M University, USA, and MBA from IIM Calcutta. He is currently doing his PhD in AI and natural language processing, focusing on generative AI, on healthcare data, and expects his PhD to be completed by this year, by 2023. With this brief note on the today's topic and the introduction of the speaker, now let me request Mr. Rajeswaran to enlighten us on generative AI and its impact. Over to Mr. Rajeswaran, please.
Yeah, thank you, Mohan. Thank you for the nice introduction. I will share my screen. And, okay. Can see my screen? Okay, good. So let me go on to my presentation. Okay. So let me just talk about the coverage today, what we're going to do. So it's going to just cover basics of generative AI, what it is, and where we are going. And then we're going to look at specific type of models and why it is so impactful. It's called instruct models. I'll talk about that. Then I'll show you some demos on what is there and how it is working, what we're trying to do, just to give you some context of that. Then we will cover different types of Gen AI. So I'll introduce you to some different types as well, which goes beyond just LLMs. Then we look at impact from dangers and impact. This is the way we are going to cover the session today. Now, I've been introduced already. Just to give a little bit perspective, I've been working with Gen AI from 2020 onwards, after GPT-2 came out. And in 2021, I wrote this article in Capgemini website that you can still see, saying that this is going to be the future as part of the expert perspectives in different things. I've written many articles in the Capgemini website, and this is one of the ones that I get maximum number of calls. People call me and say, you wrote about it, you tell us about it, and things like that. So that's, something that I've been deeply thinking about for the last few years. Okay? Now, let me just start about the model. Like, we want to talk about what is a model, and then we will slowly build upon that we are going with the generative AI model. Okay? So when we talk about machine learning and data science, when we talk about a model, what we do is we take some data, and this is typically labeled data, meaning that you have some label that says this is good, bad, red, blue, whatever. You have some labeled data, and then as a data scientist, you are supposed to pick some kind of an algorithm that would work on this data. And then what you do is you come up with a mathematical expression. That is what we are trying to do. So let's take a very simple case that I have a data that I have X and I have Y. And X is like, let's say 2, 4, 6, and Y is 4, 8, and 12. So if I ask you, given another X, but I say X is going to be, let's say, 3, then you would be able to tell me that, okay, looks like Y is equal to 2X, and you'll be able to just plug in the value of X and predict my Y, right? That is what essentially what we're trying to do. Essentially what we're trying to do is, we have some data, and then we have one item that we are trying to predict. And we are somehow using different techniques. And these techniques can be called algorithms, can be black box, white box, whatever different ones. And we're trying to extract some kind of a mathematical expression for the whole data, which actually represents the data. And typically we have some error metric that says that, how close are we to the data? So that is the way we do it, right? And the advantage of extracting this mathematical expression is that given a new value of X, you plug it in and you can automatically get the value, predicted value. Let's say I have studied a lot of weather data, and I have built a complicated equation for it. Atmospheric pressure in Bay of Bengal, 15 miles away, 100 miles away, wind speed, wind action, whatever. And I plug all that in, and then I'll be able to say, based on what I know historically, I know that 3 days from now I'll get rain in Chennai. 2 days from now I can get rain in Chennai. So that's why we are able to do that. We're able to predict something because we have this mathematical model. That model is called the mathematical thing. That is what we do. And then we are able to get prediction, which is pretty useful. This is the process. Now, the difference between something like, let's say, gravity in physics, right? Where that also is a model, but it's a deterministic model, meaning you have a very clear outcome. If you throw a ball, you can predict exact to the microsecond when the ball will land, depending upon the trajectory, depending upon the speed in which you throw, whatever you have, you can predict, you can calculate, plug in some equation, and then you'll know exactly when it will happen. But that's not the case with a lot of things that we do in the real world. The wind may be coming here, but it may get moved. The rain may happen in Andhra. All sorts of different things can happen. So the data that we have is basically not deterministic data. So we cannot expect deterministic answers. So this is the main reason why we have AI analytics itself. This is what we're trying to do in essence. Now, I said we have some data and we have to extract some equation from it. And one of the most powerful way of extracting this is what is called as a neural network. And there is a theorem. universal approximation theorem, which says that given any function, this is for very simple network, but if you can expand it, although it's not mathematically proven, but it's empirically proven, you can make the neural network learn any function. Right? It's basically a functional approximator. Those of you who are studying would have seen Fourier series, Taylor series, they're all functional approximators. So we're just trying to get an approximator. So neural network is a very, very powerful functional approximator, although as the networks get larger and larger, being able to mathematically write that function may be impossible, because it gets very, very difficult. But it is in the essence a functional approximator. So we have some data, and we are trying to get a function out of the data. That is the mathematical expression. And we are using what is called as a neural network, which is one of the techniques. There are many techniques. Neural network is one technique which is very powerful. Now, this neural network again can be configured in many, many ways, right? There are hundreds of configurations you can get out of neural networks, okay? And we are going to look at, or rather, we are going to be using one type of a configuration called as a transformer. Because this is one configuration of the network. It's called the transformer. And this particular way of connecting the network, right, has become very, very, very powerful and impactful across many domains of problems. Computer vision, language. The original transformer model, the attention is all you need, basically talked about language translation, but people have found it to be useful in they took the same configuration, applied it to a different type of network, a different type of a problem. And then they found, it can solve this as well. And then they took it to vision, and then they said, oh, yeah, it can solve this as well. Like that. It proved to be very effective across multiple problem domains. Okay? And that is what has caused all these revolutions to happen. Right? And then what happened is NLP has got what is called as tasks. Natural language processing, there are tasks like named entity recognition. You'll get a part of speech tagging, sentiment analysis. There are multiple tasks that you can do with NLP. And then in 2018 onwards, these neural networks which use transformers, right? They started outperforming human evaluation, meaning the task can be done better with networks than with humans. That's the point that we're trying to make in these NLP tasks. And the moment you get better result than humans, obviously you will get more adaptation, right? If you take, for example, the teller in a bank who basically doles out your cash, the error rate may be 1 in 10,000, or not even 10,000, 1 in a million. But ATM will be like 1 in 10 million, because very rarely ATM discounts the cash. So it's much more powerful and adaptable. That is the main thing that is happening, right? Now, based on this transformer architecture I talked about, OpenAI built an architecture, what they call it as a GPT, right? GPT-1 first came out. And GPT-1 had a stack of these 12 layers of transformers that I talked about, right? Transformer blocks. And it had an output token size of 512. That is what they started with. And then they built GPT-2, and initially they didn't release it because they increased the data that they trained on massively. And then they were worried that it is too powerful and too, what shall I say, it was really a shocking performance. They were very impressed. They initially didn't release it. After 4 or 5 months, they released the architecture and the code and things like that. The only difference between GPT-1 and GPT-2, other than the massive text, is instead of 12 layers of these transformer layers I talked about, you have 48 layers, right? And then they have a larger context window as well, meaning you have a bigger token size. And then they released GPT-3, which has 96 of these layers stacked in, and it has a larger context window, 2048, right? That is the change. This is all the, so in effect, fundamentally, OpenAI premise is very simple, that you throw a lot of data at it, create a larger network, you should be fine. You should be able to perform better and better. This is the fundamental premise on which the whole OpenAI is built on, okay? There is quite a bit of research now which basically says that this may be okay, but it's not the only way, or there are other ways. We'll talk about that, but this is the underlying premise, right? So GPT-3 has been there for quite some time, few years, right? 2021 when I wrote about it, it was there. I've been using it for a long time. But it was only used by people like us who are basically writing code using APIs, and it was not like ChatGPT, right? That is the main thing. And all of this, the underlying architecture is something very, very simple, right? It takes a word, it converts it into a vector. So one thing you need to remember, the neural network will only handle numbers, right? It cannot handle words, it cannot handle image, it cannot do anything. It handles only numbers. So when you input a word, you have to convert that word into some kind of a number. Okay? And then you have to change it and then give. Now, question is, how do I convert a word to a number? And then how do I convert it back? So you need to have some way in which you convert in a standard way and then convert it back in the same standard way. This has to happen, right? And this conversion of this conversion of word to vector is done by what is called as an embedding. So what we do is we convert the word into a vector space. Depending upon the model, the embedding size will differ. I will not get into that. Then all it does, so everything GPT does is, it takes a word or bunch of words. In GPT-3, you have 2048 token window, right? And then based on all the input text, it predicts the next word. That is all it does. It doesn't do anything more than that. It predicts the next word. So if you give a text saying that not all heroes wear, okay? And then it will predict capes as the next best word. And the second best option will be pants. Third best option will be socks, like that. This is all it does. It's based on the data it's trained on. It will say, based on all the data I'm trained on, if you give this sequence, my prediction would be capes as topmost, pants as second, socks as third. Very simple. That's all it does. It doesn't do anything more, right? And I will just show you this for a minute so that you get an idea, right? Yeah, 1 minute. Once again, let me show you, just to give you what is that. I don't know, I'll just enable, okay? Then I'm just saying complete it for me.
Hello? Hello?
I'm very sorry, I lost electricity at home. Hello, can you hear me?
Yes, yes.
Very sorry, I lost electricity at home completely.
Yes, sir. Yes, sir. We are hearing.
Murphy's law applies.
No, normally it doesn't happen, but yeah, but not good. Murphy shouldn't be playing with me today. Okay. So I'll go back to my presentation for a minute. Okay. Okay. So all it does, as I said, is just giving the probability. It's a next word prediction model. It doesn't do anything more. Now, how does it do the next word? Basically, what it does is when you see a lot of text generated, right? You'll see it writes a full paragraph or everything. It basically goes into the loop. It first say first word, then you get back, give the longer sentence, then it gives the next word. It takes a longer sentence, next gives the next word, longer sentence. It's all what it will keep on doing. That's why it's able to produce this long answer. Now, what we are doing is we are first taking the words, we are making that into a token, right? You can think of a token as 3/4 of a word. Okay, I'll not get into what's a tokenization. And then we are doing what is called as a one-hot encoding. We are transferring that into, there are so 50,257 different tokens available in OpenAI. I'm just talking about OpenAI right now. And then what it does is, this model produces some vector again, which is what I talked to you about. And the vector that it produces, there are multiple models. There are Ada, Babbage, Curie, Gravity. There are different models. Each model produces a different size of a embedding. That is what it does. That's the way the model works. Now, what I'm saying in essence is, we deal only with numeric value. So we have to convert the word into a vector. And the vector we convert will change depending on the model you choose. And it may be more advantageous to use a more bigger vector, but it has its own other issues that you have to think, because it will be slower, it will be more difficult, costlier, and things like that. Right? This is the way the whole transformation happens. This is what OpenAI does. Now, what they did after that is they created this GPT-3. It has been around for a few years now. Nothing new about it. Google released a paper called FLAN. I'll talk to them about that. And then they said, you can actually improve this model. So we built a model. And Google released a paper saying you can actually improve this model. Not by retraining the full model. No, not this way. Right? That is easy. Everybody knows that. You can retrain a full model with some new data. They said you can do what is called as a fine-tuning. Okay? There are many, many methods of fine-tuning. I will not cover all of that. Like there's LoRa, and there is this and that. So many things are there. But Google showed that you can fine-tune it in one way called instruction fine-tuning. And that will improve the model performance. Okay? And that proved to be a very important step. So when we have a model, foundation model, whether it be OpenAI or whether it be Falcon or whatever model that you use, there are only few things you can do. You can do prompt engineering to write smart prompting. There is a website called learnprompting.org. You can learn your own prompting. You can do fine-tuning or you can do embedding. This is all we can do, right? And historically, what is happening is we used to have word-to-vec. Now, word-to-vec, as I mentioned, was pioneer in saying how you can convert a word into a vector. Remember, and this is very important because it allows us now to have a rich representation of the word in the network. As a network can only take numeric value. So you need to have a word and you need to convert it to some number. What number can we convert it into? Word-to-vec showed that there is a way of training the model to give you rich vectors that that is the main contribution. Okay. Then BERT and bidirectional training of these transformers and other things came about. And BERT again takes word as embeddings. And then it gives you a model which is trained and you can improve upon it. So you can do fine-tuning. That is the main innovation in BERT. Then all these large language models came about, right? GPT-3 and this and that came about. And only main thing is there is a foundational model and then you can do fine-tuning to improve it. That is the main, okay? And there were instruction fine-tune models, but ChatGPT was the most popular. So they took a base model, GPT 3.5, and then they did some fine-tuning. And then they released a model that is instruction fine-tuned. Okay, that is the main thing. Okay, now the fine-tuning concept was initially, written in a paper by Google, right? So they took a GPT-3 model, they did some fine-tuning, and then they said you can even do better than GPT-3 by just spending 2% of the cost. Okay? And then OpenAI said, oh, okay, great. So a lot of people from Google were hired by OpenAI and things like that. And this fine-tuning is different from the BERT fine-tuning and other fine-tuning that you have to learn, because this is completely different, because it's got things like, lower ranking matrix adaptation and things like that. It's different than what you normally see. Okay, I don't want to get into that, it's too technical. So then they wrote a model that took GPT-3 and then instruction following using supervised learning. Okay, that is what they did. And that instruction following made that model much, much, much more powerful and useful instead of completely retraining the model. So what does it mean? As I said, GPT-3 just does completion, right? So if you say, I want to make a pizza, There are many ways it can get completed. One way it can get completed is it says here are the ingredients, this is how you do it. Tick, you do it, you create a bath, put it into the oven, blah, blah, blah. It can give that instruction. Or it can say, I want to make a pizza for 5 people. That could also be a valid completion. There's nothing wrong with that completion. Or I want to make a pizza within 30 minutes. That's also a valid way. If I give you fill in the blanks, all 3 here are valid completions, which is what the next word prediction model should do. But all of you know that this is the most useful, because when you go and say something like this, you are expecting it to tell you how to make a pizza, because that is a human intent, which is not obviously covered in these two, because it's giving valid answers but not useful, right? That's the point. Now, this fine-tuning, what it does is that it takes the base model, it freezes it, and then we apply some mathematical expression, like, as I said, low-ranking matrix adaptation and things like that. There are many, many techniques. I will not get into that. That's what we're doing. It doesn't change the original model. So you can do fine-tuning, I can do fine-tuning. We've done a lot of fine-tuning, right? You can take a model and do fine-tuning. That's the main point. Now, what it does is something else. Earlier, if you have to have a model, let's say somebody says, create me a model to do a differentiation or arithmetic or whatever it is, you'll create a model. And then if you say add A, B, then the output will be a sum. If you say summarize, and then text a number of words to summarize by. Part of speech, you give the sentence, right? Something like that. So all of these, you should create a different model and different function, right? That was what was changed completely. In instruction tuning, you don't have to have a separate model for all of these. One thing can do everything, right? That's the main point. And this is taken from the OpenAI paper itself. When they did the test, they said output from 1.3 billion parameter model, which was instruction tuned, outperformed the 175 billion parameter model, meaning that is the impact. 1/100th of what you have can actually beat what it is. It's amazing impact that instruction fine-tuning can have. That is the main thing. And where do you get the instructions? Basically, this is taken from the Flan paper of Google. So it takes it and then they write some code, they generate it as an instruction. Okay. So now what happened is, many people started following this whole thing. The first major item was alpaca model from Stanford, where they took DaVinci OpenAI model, they wrote handcrafted 175 instructions, and that generated a 52K instruction set, right? And then they took a basic Llama model, 7 billion parameter model, and then they created this alpaca model. This alpaca model, for $600, they created something that is as good or improves upon DaVinci, right? That is because this is a base model and this is an instruction tool model. That's the difference, right? And the same thing you can see. This is a paper called Less is More from Microsoft. So they take very small data set and then they've instruction fine-tune and they're able to beat GPT-3 and GPT-4. That is what it is, right? And then you would have seen Dolly being released. Dolly is released by Databricks. And there again, the same model, instruction fine-tune, instruction fine-tuning, and they spent $30. So we can build a model. Okay, right now, we are trying to do that. We're trying to build a model that will beat GPT-4. Okay? With very little money, $100, $500 possible. Okay? And this is the main learning from how you fine-tune an existing model. This is the main point. Okay, it's possible. There are many things to do. It's possible. Okay, that's all I wanted to. Few days back, you would have seen that Microsoft and Facebook, Meta released Llama 2. And that again, the fine tuning was done using 100,000 instructions, and it performs better than ChatGPT. The instruction tuned open source Chat Llama, right? Outperforms ChatGPT. That is the thing. You can check it out in the website, right? This is what it is. Now, I will skip the playground a little bit because we are short of time, right? I want to show you the OpenAI playground, but I will skip that a little bit, right? So, what is the difference between, say, generative model and discriminative model? In discriminative model, what you do is you give label data. You say, this is good and this is bad. This is, sentiment analysis. This is positive sentiment, negative sentiment, neutral sentiment, like that. And then you train the model, it sort of finds the boundary and then classifies. But in generative model, you don't do that. You basically ask a question. What could be the distribution of the data that generated this? Right. That is the question. The question you ask is something completely different. And from a difference perspective, right? You don't do all of this. You don't do task definition, data preparation, training, all that is gone. So you do very little data preparation, instruction tuning, and then there's absolutely no training. It's only prompt engineering and fine tuning. Right? This is the main way of looking at what is happening in generative AI. The other thing is, it is not only on the language. Right? For those of you who have seen Mid-Journey, Stable Diffusion, there are multiple domains from code generation, image generation, speech, video, 3D, other. All of these have been affected by large language models. Okay, LLMs. LLM meaning transformer architecture configured in different ways, trained on large data. That's what we're talking about, right? So it sort of completely changed the whole AI landscape, the way that we do things. Okay? And within OpenAI itself, right, there are 64 different models that they have. And 4 of them are what is called as a foundational model. Like you have Ada, Babbage, Curie, Da Vinci. And then you have embedding model, instruct models, right? But main thing here is, once you instruction fine-tune a model, you cannot improve upon it. So you can only fine-tune these core 4 models. Ada, Babbage, Da Vinci, and Curie. Okay? You can't do fine-tuning of any of those. That's what it is. Okay? And most of these are instructive tuning models, That's way OpenAI has architected it. Now, these models that I've shown, there are different use cases that you can use it on. Right? Code search can be used for relevance. Text search, because a lot of people have, customers have large amount of data that they want to, internal data that they want to be able to retrieve, get the context and things like that. So such search use cases are very prominent, right? And code generation, if I want to improve productivity of developers, I want to do generate code, okay? And text generation is like, for example, I want to generate text for ad campaign, product placement, so many different use cases where you want to generate text, right? Even writing letters, replies to customer, whatever. Similarity use cases where you want to do anomaly detection, virtualization, a whole bunch of use cases are there. Code similarity, all these are different types of models. Now, OpenAI themselves, this is taken from the OpenAI, they've given the mapping of what models you can use for what kind of a thing. That is sort of given by OpenAI itself, right? So now I will cover a little bit on the dangers, right? So this is Okay, before I go to the playground session, what we're all so happy about the buzz it has created. Personally, I've become a rock star within Capgemini because of that. Okay? But what happens is that OpenAI released a paper, and then you can go through this paper, where they looked at the impact of these generative AI technology across a wide range of job descriptions. And a lot of jobs will disappear. Okay, for example, annotation, people who do image captioning, annotation, all of those will be gone because models will do that for you. Okay, even creative writing, or even, for example, that will be a lot of impact. There are thousands of books in Amazon today, all written by AI, not written by humans, right? Because you can just give topic, spend some time, write some good books. So it puts the people who sit down manually write it at quite a big disadvantage and risk as well, right? Because if you have too much noise, finding out the signal from the noise becomes difficult. So even software development is going to be impacted quite a bit. Not in the immediate next 2-3 years, but in 4 or 5 years, there will be a serious impact because the job descriptions will change. And what you need to know, what you need to learn will also change. That will happen pretty much with every technology, but that's going to happen. Okay, that is going to be there. Now, there are other impacts as well, right? Because this is something that's coming from the OpenAI paper itself. Now, this language model, as I told you, is trained on trillions of tokens, 3 trillion, 4 trillion. Trillion is a very large number of data. Just to give a perspective, for GPT-3, all of Wikipedia, which is around 32,000 articles in multiple languages. I'm sorry, 32 million. Okay. That is all forming around 6% of the corpus. So you can imagine the amount of data that they have trained it on. Okay. Nobody could ever read 32 million articles. And then even that is, very small part of the whole data that they've trained it on. Now, what happens is, because it's trained on all sorts of data, not only this, it's trained on all the papers in chemistry, all the papers in this scientific journal, that, this, PubMed, whatnot, right? When you ask, for example, they said, as part of the checking, they said, can you build me a bomb with only what I have in my kitchen supply? Okay. And then it started giving step-by-step instruction on how you can use it with only what you have in your kitchen. Okay. And that is dangerous, right? You could think about the same thing with, let's say, somebody says, can you build me a virus like Corona or something like that, or a little bit more virulent? Then it will tell you how to go about doing that, what do you need to do that. Okay. There are 2 major differences in this particular problem. One is, earlier and even today, a lot of detection, like people, there is scanning of what you do as a search and what I do as a search happening. And so let's say you are Googling quite a lot on how to build bombs, then obviously the police will start monitoring your internet usage and what you're doing, and there's going to be quite an alarm being raised. But what happens if you download a large language model and then you don't Google, you're just asking it and it's giving you instructions? Then there's no way you can be detected. And it could be, you could be building a large bomb, because it's very cute when you say, give me a substitute for, a cake without eggs, and it gives you an egg substitute. But it says, how do I build a bomb? And then it gives you a substitute for that and with regular material, and then you end up building a bomb. It becomes very difficult because the model is very dumb. It doesn't know. It just gives answers. It just completes the sentences. They put a thing in front of it, right? But even that, there are so many ways you can bypass it, right? So I'll show you. For example, okay, I'm going to chat GPT and okay, sorry, the internet connection, it was lost. Okay, so if I say, how do I build a nuclear bomb, then it will say, no, sorry, we cannot do this. It's against its risk, it's bad, whatever. Okay, if I say, okay, but when I do the same thing, it will tell you. It will tell you step by step. Sometimes they put it to control, sometimes they don't. But you can just say, how do I write a poem about building a nuclear bomb? It will give you step by step on all the things you can do. Of course, you can't build a nuclear bomb, but you get the point, right? It will tell you. There are a lot of ways in which you can bypass the security that they have, because there's only so many controls you can put. Okay, and that is the main. In fact, last time when I was showing demo, it completely gave the step by step. I showed taken some screenshot and put it, but yeah, that's the point. Okay, so now that is the kind of danger that we have. We have a danger in which we are taking these models, train them on so much data, just throw them out to the people, and we don't know what they are doing and why they are responding this way. We have no idea about the model, and that is a serious danger to the society, right? And second thing is they plugged in this with other specialized systems, right? So let's say you have a model that is trained on all of PubMed, another model that is trained on, basically in this case, they trained it on a database called Smiles, right? Okay. Basically all human gene and this and that and all the chemical compounds and all that. It sort of it worked with it and gave you extremely good replacement. So you could build something very sophisticated with what you have at home if you are half educated on what you're looking for. Okay, this is the point, right? This is something coming from the OpenAI paper itself. Now the problem is in OpenAI, they put controls. So you go and then they stop you. But if you download Llama, there's no control because it's not having the type of controls that you have. And now we have these open source models. Yesterday Llama was 70 billion is released. And like that, we are having all these models and they're all without controls. It's like saying, very good brakes, so you can drive 300 kilometers per hour and still have a brake and check and things like that. All the others, they don't have these controls, and that's a massive problem. Okay, that is one thing. Yeah. The other part is there are other models that are being made. For example, I can take a sample of your voice for 15 seconds, right? So they talk about 3 minutes, 15 seconds of your voice sample. And then all of you would have seen videos where Donald Trump or Obama or somebody is talking as it's all generated output. So imagine, people, imagine you get a call and then it's your son, daughter, wife, whatever it is, and then from some unknown number and says that, oh, I just got into an accident, my phone charge is dead. I need to rush to the emergency. Can you please transfer 25,000 and then the call shuts off? It's that person's voice. And you will transfer, let's say, 25,000, 30,000, whatever it is, because it's really the voice of the other person. It for sure. And then it's gone because they just cloned the voice and then it generated it. But then they could also have a complete chatbot that chats with you. So you can ask questions, they will be typing answers, and you get answers. And you'll be convinced it's the other person, but it's not really the other person. And so those kind of scams can happen, and it's already starting to happen. So all this is because of generative models. Because what we're doing is we're taking this, we're training it, but there are quite a few other people who are looking at it in a different way in terms of how we can hack it, how we can misuse it, and things like that. That's going to be a massive area of concern. Okay, so it's not just about job loss, because I don't think there will be so much job loss now. There will be job changes. There will be, we talked about IT wherever it went, right? You take Excel, right? Excel does accounting. People used to write ledger books manually, and then Excel does all of that. But wherever Excel went, there will be more people doing Excel, and the IT. Take banking, for example. Branches never disappeared. We had core banking, we had this, we had that, back office, but there are more and more branches as opposed to less and less branches. Okay, although there is a lot of automation in that. So same way, large language model is going to automate some things, but it's not going to make, some jobs will disappear, no denying it, right? But it will not have that kind of a complete overhaul that people actually believe, because one, it is imprecise technology, two, people will adapt, and the new jobs will start coming up because of this. Some things will happen, like, so that balance is going to happen. That itself is not the problem, but we have to be aware of there is a serious opportunity for mischief and danger with these models. That is what I'm trying to tell you, right? So what we try to cover today is, I gave you a perspective of how neural networks, being a fantastic functional approximator, is being used with a configuration called as transformers to basically predict the next word. That's what GPT and GPT all over work. And OpenAI started with GPT-1, which is a very small model, and then they kept increasing the number of layers stacked transformers as well as the width context window, which is important. And then instruction tuning came. So they built this GPT-3 model and then improved it to GPT 3.5. But that itself is not a big thing. They fine-tuned it with instruction following. So you can just tell add 2 and 2. You can say add 2, 2. Sum 2, 2. Anything. It just understands your instruction. And it's able to understand and follow it and give you that result, which is what made it all the more powerful, and whole ChatGPT architecture depends upon it. And then came along all the others who started building these foundation models and fine-tuning those models for instruction following, which makes it all the more powerful again, like what I said. So instruction fine-tuning is like you have a fantastic, T20 player, and then like Don Bradman of T20, but you can make them play test as well, as long as you have to tell them the new rules. Say, go slow, whatever, like that. So, but if they're very good at T20, there should be no reason why they can't be good at test, as long as you can allow them to learn the new tricks. Same way, instruction following is the model already had the capability. It's not something new, but instruction fine-tuning made it rise up to a different level. That is the main advantage of this model, right? And that completely changed the game in terms of what is possible, what's not possible. Having said all of that, these models, nobody has any idea what data goes in, because when you're talking trillions of tokens, as I said, all of Wikipedia is such a small data set, then nobody has any idea. Nobody on earth can ever read all of that or even have any idea what is going on. Okay? And neither OpenAI nor anybody else. So in reality, the whole model is like, what do I call it? The whole model is like an elephant. All of us are blind people. I'm using it for something, you're using it for something else. That's the way the model is going. Okay. Sorry, I'm just losing current. I'm using my modem. So I linked up to my modem. So I'm not losing you as a participant, but sorry, I'm just going off and on. Okay, so let's open up for questions. I hope it's been useful.
Thank you, sir. Thank you for your nice presentation and a very elaborative presentation, sir. Sir, there are few questions that has been asked in the chat box. I'll first ask that.
Yeah.
So the first question, sir, am I audible, sir?
Yeah, I can hear you. Go ahead.
Yes, sir. Is ChatGPT trained on data up to 2021 only? If so, how does it respond to queries based on information after 2021?
It doesn't. It doesn't. See, what happens is earlier they used to get fooled. When they first released it, was giving all answers. Then they put a control and said that if a question comes after that, just give a standard reply that says that I'm only trained on this and it will give you that. But that is not ChatGPT answering. That is OpenAI answering. Sorry, as a layer on top of it. Okay. The model is very simple. It doesn't even know anything about timeline. It doesn't know anything. It will predict the next token only. Okay. And if you have question beyond it, it will also try to predict the next token. That's all it's trying to do. Okay. So it doesn't care whether the token came from 2021, 2020. It doesn't know anything about that. It's all done outside the model. Yeah. Sorry, I lost electricity. Go ahead.
Again,
1 minute. Sorry.
Yeah, go ahead.
The next question. Yeah, next question.
You want me to read the question? And
Yes, sir. 1 minute, sir. I'll read it, sir.
Okay.
May I know your advice for academicians to conduct research using these LLMs with limited processing facilities offered by Google Colab or Kaggle?
Yeah. So that's what I'm saying, right? See, there are multiple things you can do. Okay. You can actually do a lot of your research with ChatGPT itself. There are APIs that allow you to do that. You can use a very simple model. You don't have to use the largest model. You can use the 7 billion parameter model. Not only the response time will be faster, but it should give you direction on which the response will be. Okay, it's very much possible to do that. Okay, and for those researchers who are interested, there was a model released by the Abu Dhabi Institute. It's called Falcon, and if you have a good research problem, they're willing to fund it. Okay, so you can go to the Abu Dhabi Institute and then search on Falcon funding, and you should be able to get very good funding, especially if you have something that is related to culture, and if you can, frame your problem around something that is useful for society, you should be able to get funding. They have very good funding, very good funding.
Thank you, sir. Next question. Is there a standardized way to identify hidden bias in AI responses, which may be due to inaccurate data used in training?
Honestly speaking, there's no such thing as inaccurate data. Okay, there is only data. Okay, whether the data is accurate in the sense that it reflects what's there in the internet. Nobody corrupted the data. They just take the data from the internet. The internet data is biased. Okay, if I ask you, if you go to Google and if you go to ChatGPT and ask who won the Wimbledon in 2014, it will basically say, I don't know, Roger Federer, whatever, right? But then obviously you can find that it is biased against women, because I just said who won. Did I say I want male? I didn't say that, right? So there are many such ways you can find out, very simple questioning. Okay, you can say who won the 100 meters in 1984 Los Angeles Olympics, and you'll get Carl Lewis. But what happened to the women? Because you didn't say male, right? So there are many ways you can find that it's biased. It's biased in many, many ways. That's because we are biased. Okay, and the data that they've collected is biased. Okay, and to say that everybody, including me, you, all of us are biased against one thing or the other. There will come a time, don't get me wrong, where we will all be biased of having data that is anti, what shall I say, transgender. Okay? Because all the data we have either assumes it will be male or a female. Right? So I am going through, reorientation where I have to think that, okay, mother can be male, father can be female, all sorts of different things. So it's difficult to wrap my red head around these things, but that's what it is. That's what the data says. If you train it on any data like this, all your data and your predictions will be assuming there is no transgender. So are we not all biased? We are all biased because that's what we see around us. Okay, so the bias is everywhere. You may or may not recognize it. All of us are biased on one way or the other, right? So what data are we going to feed? We're going to get biased data. So to say that data is wrong is not the way to look at it. Data is what it is. You have to figure out what you want to do with it. You want to make a nice paper about biased data? Go ahead. It's a good thing to do. A lot of people will love it. And there are quite a few data sets that talk about it. It's a good thing to do. But that's what the data is. Okay, it's a commentary on the society. It's got nothing to do with the model.
Thank you, sir. Next question. What is the type of training used for DAL-E by OpenAI since it's more image-based?
Yeah, there is a controversy on that. See, DALL-E again is same architecture of GPT-3, and then they went ahead and built it. Only thing is they trained it on images, and then you can do instruction following, meaning you can just type out some text and it will generate image. You can say, generate me an image of me sitting in the moon, drinking coffee or something. It will generate an image of you, whatever. So that's what it is. So what they've done is they've taken a lot of images from the internet, and there is a controversy around it because people said that I never gave you permission to take it. Okay, and they're trying to come out with that issue. There is quite a bit of investigation thing going on. So it's again trained on these millions and millions of images. It does the same thing as language model. Nothing different from it. But that nobody uses. The Stable Diffusion, Midjourney, they're all way better, much better for image processing. That is my take on it. DALL-E is a big failure.
Okay, sir. One last question. Sir, is buying ChatGPT Plus beneficial for students, freshers, and researchers?
No, I don't know. See, ChatGPT plus what it will give you, you can get access to GPT-4, right? And what do you mean give up is better? Are you going to write assignments with it? Are you going to generate code with it? I don't know what you're going to do. It all depends on what you want trying to use, right? So do you want to have access to GPT-4? Yes, you can. And it will give you GPT-4 access. I have ChatGPT plus, but I mean, beneficial meaning, I don't know. You can play around with GPT-4. Okay. You can play around with it. It's good. That's all you can say. Yeah.
Thank you. Thank you, sir. Thank you, sir. Thank you for your wonderful answering for all the queries. Now I request our chair, CSI Chennai chapter chair, Mythili Prakash ma'am, to propose the formal vote of thanks.
Thank you, Agila. Thank you, sir. Really excellent evening for us today. Right from the introduction of generative AI model, followed by comparison with the discriminative model, GPT models, instruction following models and back playground, till some dangers of Gen AI. Really, we are proud of what you are spending. Thank you so much for spending your valuable time with us this evening, sir. We really enjoyed this session. Thanks for the joining societies, IEEE CS, Madras, ACM, and the Hindustan Chamber of Commerce, and its members from the joining society and the CSI. Thanks to all the participants and for your interactive question and answer session, which added more value for this webinar. Thank you. Thanks a lot for everyone. Thank you, sir.
Thank you. Sorry, the lost electricity in between, so quite a few problems. Sorry about that.
It's okay.
Okay, thank you. Bye.
Thank you so much, Rajeswaran.
Thank you all.
Thank you.